Okay, guys, so this video is to help you guys with the harder trig problems. I am doing this so you guys can have not just one but two examples. This is the example we went over in class, so I'm just going to go over it again for those who might not have fully understand what it is that we were doing. So in this particular problem, you are basically trying to find the value of x. Now, unfortunately, x is located on this particular triangle that only has one piece of given information, which is the 54 degrees. The downside about that is that you need at least two pieces of information to be able to use Sohcahtoa to find a missing side length or a missing angle. However, there is this other triangle over here that has two pieces of information. It has the 24-degree angle and it has the 21. Now what we can do is we can actually use that blue triangle to find this side right here that is shared between the blue triangle and the black triangle. And by finding that side using the blue triangle in Sohcahtoa, we're able to then find x, which is on the black triangle, which is what we are initially trying to determine. So, in order to determine that squiggly line, that shared side between the blue triangle and the black triangle, we are going to use Sohcahtoa. Now, I am isolating that blue triangle so then that way you guys can see that we're trying to find that squiggly side, which I've labeled Y in both triangles. Okay, so remember what we talked about in class today was that when you are trying to figure out a side length or an angle, you want to label your sides based off of the acute angle given or the acute angle you're trying to find. So since we're given 24 degrees, we want to label our sides. Y is the opposite side because it's across from that acute angle, and 21 is the adjacent side. What we talked about in class was how to determine what trig ratio to use. Well, since we're looking for the opposite side and we have the adjacent side, we want to use the trig function that has opposite and adjacent in it, which is tangent. So now that we know we're using tangent, we want to set up the equation, which is going to be tangent 24, tangent of your angle, equals your opposite side over your adjacent side. So it's going to be tan 24 equals y over 21. Now what we need to do is we need to solve for y. So to solve for y, we are going to multiply both sides by 21 and go to our calculator and type it in. Now, the calculator that's on your phone and the calculators that we use in class, what you are going to have to do is you're going to have to work backwards. You're going to have to type in 24 tangent times 21 to get your answer. And when you do, you get 9.3498 and some other numbers. Okay? Now, if you're wondering why didn't you round that number to three significant figures, the reason why I didn't round is because I need to use it to actually find what I'm looking for in this problem. And the more you round in the problem, the further off your answer is actually going to be from the best correct answer. So what I'm actually going to do is right now in your calculator you should have 9.348 whatever or 9 in your calculator. So we're not going to touch it for right now. We're going to actually save that there for when we actually set up and solve for x. Because now that I know that squiggly side, the side that's shared between the blue triangle and the black triangle, I can now use Sohcahtoa again to find the value of x. So I'm going to isolate the black triangle, and I'm using pink here to distinguish. So this one is the 9.34 number, and this is x. Again, I'm going to label my sides based off of the acute angle. X is across from my hypotenuse, or from my 90-degree angle, so it's my hypotenuse. And 9.34 is my adjacent. Adjacent and hypotenuse is cosine. So I'm going to set up my equation as the cosine of 54 degrees equals my adjacent side over x, my hypotenuse. To solve for x, I'm going to multiply both sides by x to get it out of the denominator. And then what I'm going to do is I'm going to divide both sides by the cosine of 54. So in my calculator, I need to do that. I need to divide that 9.3498 number by the cosine of 54. Since we still have that number in our calculators on our screen right now, if I just press divide 54 cosine and then click enter, I'll get my answer for x. And by doing it that way, I'm not rounding prematurely. I'm going to actually round my final answer, which is going to be 15.9. So x equals 15.9. Now, if you have a standard calculator, maybe a graphing one, or maybe a more advanced scientific calculator than the TI-30XAs, then you'll just type it in exactly how you see that I've written it on the board for X and for Y. But if you're working with those TI-30s, you're going to have to type it in backwards. Okay? So, now let's look at this one. Now, this is a new one. I just want to make sure that you guys are understanding exactly how we do these harder trig problems. Basically, where we have to find another piece of information before we can actually find our answer. So, we're looking for x. X is an angle. And if you look on this particular triangle, which I'm going to highlight in yellow, that has the x, we don't have two pieces of information. We only have the one, the 41 side length. So, in order to find x in that triangle, we're going to need to look at this green triangle that has two pieces of information. It has the 66 degrees and it has the 80 side length. And again, you see how the yellow triangle and the green triangle share this side right here? Well, that's what I need to do. I need to find that shared side length and then use that answer to find the value of x. So what I'm going to do is I'm going to take my green triangle, I'm going to isolate it. I'm going to redraw it, making sure I include my acute angle, my 90-degree angle, and of course the 80. And I'm going to label the shared side y, just to make sure that, you guys are able to follow along. So now I'm going to label my sides based off of my acute angle. 80 again is across from the 90-degree angle, which makes it the hypotenuse. And y is my adjacent side. Remember, adjacent means next to. So now that I'm looking for my adjacent side, I have my hypotenuse. Adjacent to hypotenuse, that's going to be cosine. So I'm going to set it up. The cosine of 66 degrees equals y, my adjacent, over 80, my hypotenuse. To solve for y, I multiply both sides by 80. And so I'm going to type into my calculator 66 cosine 80. Again, if I have the TI-30XAs, or even if you're using your cell phone that you want to type it in that way, type it in backwards to get your answer. If you're using any other type of calculator, you want to just type it in normally. And we'll get that y, that squiggly side, is 32.53 and some change. So 32.538, that's the value of y. Now remember what I said about that other problem. I am not going to round y. I'm not looking for y. I'm looking for x. And so in order to find x, I need to use the non-rounded answer, okay? But now that I know it, now that I know that side, I'm able to find x, again, using trig. Let's label our sides based off of the angle that I'm looking for. Never the 90-degree angle, always an acute angle. In this case, since I'm looking for one, it's going to, that's the angle I'm basing it off of. That 32 number is my opposite side because it's across from my angle. And then 41 is my hypotenuse. Since I have both my opposite and my hypotenuse, that means I'm going to use the sine. That means I'm going to use the sine ratio, because sine is opposite over hypotenuse. Now for this one, since I'm looking for an angle, that means I'm going to need to do the inverse of the trig function. And just like before, you should still have that 32.53 number in your calculator. So we're going to need to divide that number by 41. So if you just do divided by 41, you should get a decimal, like a 0.79 decimal. Now we just need to do the inverse. So we're going to do second sine, and we'll get the inverse of our trig function. And the value of x, what I'm looking for, this is what I round to 3 significant figures, and it should be 52.5 degrees. So for these harder trig problems, what you want to do is you basically want to find what side they share. So then that way, on one triangle, you can solve for that side that they share. Like in this case, it was y, it was the green squiggly line. And then use that and Sohcahtoa to find what you're missing, whether it's an angle or a side. Make sure you bring any questions that you have on these types of problems to class, next class, and I'll make sure to go over them in a